Bismillahirrahmanirrahim. Assalamu alaikum. Welcome, dear students, in your chemistry class. Today, we are going to start the new topic from the chapter Periodic Table of Elements, chapter 17, and that topic is Group 7 elements or halogens. So, let's move towards our topic. First of all, we will discuss the introduction of Group 7 elements. They are also named as halogens. So the elements in group 7 of the periodic table, they are located on the right side of the periodic table and they are called halogens. Which elements are included in this group? The 7 group includes fluorine, chlorine, bromine, iodine and astatine. Okay, and these elements, they are all non-metals. Okay, now the question arises that why these elements are called halogens. The group 7 elements are called halogens. What's the reason or why they are called so? Because the group 7 elements, they form salts when they react with metals. So the term halogens means salt former. ओके जब ग्रुप 7 एलिमेंट्स जो ग्रुप 7 के एलिमेंट्स हैं व्हेन दे रिएक्ट विद मेटल्स usually with the alkali metals or group first A elements, they form salts. So due to the formation of salts or due to their salt forming property, these elements, they are named as halogens. Okay, so whenever we talk about the halogens, they are the elements that are present in group 7. Okay, and it includes fluorine, chlorine, bromine, iodine and astatine. So we are going to discuss about the physical properties and some chemical properties of the group 7 which are included in your syllabus. Okay, let's move towards their properties. First of all, we will discuss the physical properties of group 7 elements. Physical properties are those properties that can be seen, that can be observed. Okay. First property is the halogens are non-metals. Okay. Halogens क्या है? इनकी nature, these elements are non-metals. The next one is they exist as diatomic covalent molecules. Okay, they exist in nature as diatomic molecules. Diatomic molecules are those molecules, di mean two, that consist of two atoms like F2, Cl2, Br2 and I2. Okay, the next one property is about their melting and boiling points. The halogens having low melting and boiling points. And the last one is they are also colored. Okay, here is the representation of some of the halogens like chlorine. It is a greenish yellow colored gas. Okay, bromine, it is you can see that it is a reddish brown color liquid, and iodine, you are seeing here that it is a purplish black color solid. Okay, so if we talk about their physical properties or when we move from top to bottom within the group from chlorine toward iodine, so fluorine is the first one member of this group 7 elements, and chlorine is the next element, then bromine and then iodine. So fluorine and chlorine, these are gases. Bromine is liquid of reddish brown color and iodine is a purplish black color solid. Okay, so that was the brief discussion or brief description about the physical properties of group 7 elements. Okay, the next is how the physical properties changes when we move from top to bottom within the group. Okay, so let's discuss this point. On going down the group, the melting and the boiling points of halogens increases. Okay, जब हम group 7 में move करते हैं top to bottom, यानी from fluorine to astatine, Okay, so the melting and boiling points they increases. So due to this reason, you can see that the first member or the top member, that is fluorine, it's gas, chlorine is also gas, bromine is liquid, while iodine is a solid at room temperature. Okay, so ये point clearly यहाँ पे represent कर रहा है कि physical properties जो हैं group 7 elements की, उनमें से अगर हम melting और boiling points को discuss करें तो down the group move करते हुए इनकी पहले तो physical states change होती हैं, gaseous से liquid और liquid से solid, so that is closely related toward their melting and boiling points. In this way, their melting and boiling points also increases when we move from top to the bottom within the group 7. Okay, and the colors of halogens become darker. So here two properties we discussed, the melting and boiling points, their values also increases. And if we talk about their colors, so the colors of group 7 elements, they also becomes darker when we move from top to the bottom, or when we move from fluorine to astatine. Astatine is the last element of group 7, and like other halogens, it is also diatomic, and it exists as uh, astatine molecule. And you can see here that it is also of black color, solid. Okay, this element of group 7 is rarely discussed. Mainly chlorine, bromine and iodine are discussed. Okay, so that was about the physical properties of group 7 elements, that how they look like and what is the physical state, what about their melting and boiling points, and what is the color of all the group 7 elements. Okay, next we discuss the chemical properties. Chemical properties means that how these elements react with other, and what is the nature of their reactivity and which kind of reactions they show. Okay, so halogens are reactive nonmetals. Why are they so reactive? What's the reason that why they are so reactive? Because if you talk about the electronic configuration, or you can see that the valence shell of each halogen, it contains 7 valence electrons. Group 7 elements, we are talking about group 7, and the group number also tells us number of valence electrons. So group 7 elements, definitely they will contain 7 valence electrons. This means that they only one more electron is needed to achieve a stable noble gas configuration, or to complete their octet. All the halogens, they needed one electron. Okay, so halogens react with most metals to form salts called halides. Most of the reactions of halogens react with metals and they form different salts, and these salts are named as halides. So fluoride ions are formed, chloride ions are formed, bromide ions are formed, and iodide ions are formed in case of different salts, or these are also named as halide ions. Okay, as we have discussed earlier, that they having 7 valence electrons, so when they any of them when gain one electron, then they are converted into their respective halide ions, either fluoride, chloride, bromide and iodide. Okay, the next one is the most important reaction that is shown by halogens, and that reactions are called displacement reactions. Okay, a displacement reaction, how can we define it? It is a reaction in which one element takes the place of another element in a compound. एक ऐसा reaction, ठीक है, जिसमें एक एलिमेंट किसी दूसरे एलिमेंट को डिस्प्लेस कर देते हैं, ठीक है, किसी भी कंपाउंड में. A more reactive halogen will displace a less reactive halogen from its halide solution. We will discuss this point in detail in such a way. For example, when chlorine water is added to aqueous sodium bromide or potassium bromide. Okay, a reddish brown solution is obtained because chlorine, being more reactive than bromine, it displaces bromine from the bromide solution. Okay, if we talk about the reactivity of halogens, then the member which exists at the top of the group is more reactive, and when we move from top to the bottom, then the reactivity decreases. So here we discuss that being the element which is more reactive, it can displaces the other element which is less reactive, or the other halogen which is less reactive from its halide solution. Here this point is further explained by taking this example. Chlorine, it is halogen, and when we react it with a solution of sodium bromide, okay, then what happens? Chlorine plus sodium bromide, it forms sodium chloride plus bromine. So what happens actually here, when chlorine Cl2, chlorine water, when it reacts with sodium bromide solution, then this chlorine, it displaces bromine from this sodium bromide and it converts into sodium chloride. Okay, आप अगर यहाँ पे देखो तो दिस वन, यहाँ पे क्या हुआ कि ये जो क्लोरीन है, ठीक है, इसने सोडियम ब्रोमाइड में जो ब्रोमीन था उसको क्या कर दिया है, डिस्प्लेस कर दिया है. डिस्प्लेस मींस कि दिस एलिमेंट हैज टेकन द प्लेस ऑफ दिस ब्रोमीन इन दिस कंपाउंड. ठीक है, क्लोरीन ने यहाँ पे सोडियम ब्रोमाइड में से ब्रोमीन को डिस्प्लेस कर दिया, खुद उसकी जगह पे आके लग गया. ठीक है, इन दिस वे दिस ब्रोमाइड आयन here it is converted into bromine. Okay, this bromine is present in free form, so reddish brown solution is obtained. So that is the example of a displacement reaction. Displacement means that one element takes the place of another element in a compound. Here chlorine has displaces bromine in sodium bromide, and this compound is converted into sodium chloride. Why this reaction happens? Because chlorine was more reactive than bromine, so it displaces bromine and convert it into a new compound. Okay, so next we further discuss this point by taking some other examples. Chlorine also displaces iodine from an iodide solution. ठीक है, आप अगर यहाँ पे देखें तो क्लोरीन जो है वो टॉप पे आ रहा है. ठीक है, then bromine, then iodine, and then astatine. Here the reactivity order is also represented. The reactivity decreases down the group. यानी जो टॉप के मेंबर्स हैं वो मोस्ट रिएक्टिव हैं और जो बॉटम पे आ रहे हैं वो क्या होंगे, लीस्ट रिएक्टिव होंगे. सो एनी एलिमेंट विच इज lying above the other element, it can displaces it. Okay, so when chlorine reacts with potassium iodide, okay, it forms potassium chloride and iodine. The reaction is represented here. Cl2 chlorine, when it reacts with potassium iodide, because chlorine is more reactive than iodine, so it easily displaces iodine from potassium iodide, and the product is formed, that is potassium chloride, and iodine converts into iodine. Okay, similarly, the next reaction, bromine displaces iodine from an iodide solution. You can see here that bromine is present above iodine. So bromine can easily displaces iodine from any iodide solution. Like bromine, when it reacts with potassium iodide, okay, it forms potassium bromide and iodine. Okay, here bromine easily displaces iodine from this iodide solution. And why this reaction happens? Because bromine is more reactive as compared to iodine. Okay, however, when bromine water is added to potassium chloride, no reaction occurs. That point is very important to understand. I again repeat it. However, when bromine water is added to potassium chloride, here the point being discussed is that कि जब हम ब्रोमीन को रिएक्ट करवाएंगे पोटेशियम क्लोराइड के साथ, ठीक है, सो ब्रोमीन क्लोरीन से क्या है, लेस रिएक्टिव है. सो इन सच काइंड ऑफ रिएक्शंस, ठीक है, इन सच काइंड ऑफ रिएक्शन, बिकॉज ब्रोमीन इज लेस रिएक्टिव देन क्लोरीन, so bromine cannot displaces bromine from a chloride solution. Okay, a less reactive halogen, it cannot displace a more reactive halogen from its halide solution. ठीक है, यानी इस तरह का जो रिएक्शन होगा, अगर हम इस तरह के रिएक्टेंट्स को रिएक्ट करवाएंगे, then no reaction will take place. Why no? Because a less reactive halogen cannot displace a more reactive halogen from its halide solution. Okay, so we can deduce the order of reactivity of the halogens from their displacement reactions. Unlike the alkali metals, the reactivity of halogens decreases down the group. Okay, that point is very important. If we compare the reactivity of group 7 elements with group first elements that was of alkali metals, then we come to that point that in alkali metals the reactivity were increasing from top to the bottom, while in group 7 elements or in halogens the reactivity decreases down the group. Okay, so fluorine is more reactive halogen and astatine is the least reactive. Okay, so based upon their chemical nature, we discussed the some of the chemical properties, and the most important property, and that property is very very important according to your exam point of view, and that property was displacement reaction. Okay, at the end, we discuss that halogens, they are also named, or they are also called, or they are also known as a powerful oxidizing agents. Okay, oxidizing agents, we discussed some of the properties or some definitions in our previous chapters, that oxidizing agents are those elements that undergo reduction, okay, or they oxidizes any other substance. So we define halogens as powerful oxidizing agents. How can we explain this? During a chemical reaction, halogen atoms, they gain electrons to form halides. As we discussed earlier, that halogens, they needed electron to complete their octet. So when they gain electron, they form halides. So they act as powerful oxidizing agents. Suppose we having any halogen which is represented with X. When it gain electron, it converts into halide. Okay, so the displacement reaction between halogen and other halides can also be classified as a redox reaction. जो हमने reaction अभी previously discuss किया है, displacement reaction, हम उस reaction को study कर रहे हैं again in term of redox reaction. Okay, for example, in displacement reaction between chlorine and potassium bromide, chlorine acts as oxidizing agent while bromidine acts as reducing agent, because chlorine oxidizes bromidines to bromine and is itself reduced to chloridine. This point is discussed with this equation. When chlorine reacts with potassium bromide, okay, then what happens? Chlorine basically convert into chloride, and how it converts into chloride? By gaining these two electrons. Okay, because chlorine is gaining electron, so that reaction is named as reduction. Okay, and bromidines, they loses these electrons, and after losing the electrons, bromidines, they are converted into bromine molecule. Okay, the overall ionic equation for the reaction is represented here. Chlorine plus bromidine, they convert into chloridines and bromine. So here chlorine is converted into chloridine. It means that chlorine is undergoing reduction, while bromidine, they are undergoing oxidation. So here chlorine is acting as a oxidizing agent. Okay, so that were some important properties of group 7 elements and or halogens, and that was all about today's lecture. I hope you all understand it very well. Goodbye. Thank you.